Okay, so we are using solver for what if analysis. Our goal right now is to set the profit. This is the data we are using. We have the sales, we have what was our sales here? Does anybody remember?
That's 2,000.
Was it 2,000?
2,000. 2,000, yeah.
Yeah, the sales was 2,000.
Okay.
Price is 5,000.
Yeah. 5,000.
The unit cost is 1,450.
1,450. Yeah.
450. Yeah. Thank you. Yeah. Thank you. All right. So now our objective. Let's copy this so we don't lose it. Our objective is to have profit of 10 million, right? So, and we are going to change the sales, the price, and the unit cost to achieve that. Okay. So let's go ahead to solve that using solver. Okay. Of course, we cannot use GoSee for that because we need to change multiple cells, multiple variables. So we cannot use GoSee. GoSee can only handle one variable. A situation where you change one variable, nothing more than one variable. Okay. So let's go solver. What cell are we setting? Profits. Setting it to what? 10, 1, 2, 3, 1, 2, 3 million. Make sure it's a left value of 10 million. By changing what cells? By changing these cells. So let's add our constraints. Constraint number 1, the sales. Want sales to be a whole number. Okay. Sales is an int. Exactly. We don't want it to come out like this. 23.9 something point something. No. This is quantity sold. So we want it to remain a whole number. So you choose int here. That's a constraint. Let's add another constraint. Constraint number 2. The price. We don't want price to go.
It be more than.
Should not be more than what?
It will be greater than 7,000.
Okay, let's use 7,000. 7,000. It should be less. It should not be greater than. Okay, less than or equal 7,000. Yes. Okay. Yeah. Then.
No.
Then.
No.
Unit cost. Oh yes. Anything. I can't hear you.
No, the sign you use there is
It's less than or equal to.
But that's the price you use less than. It shouldn't be greater than 7,000.
That's what I did. Less than or equal 7,000. That means less than or equal 7,000. Look at it here. Less than or equal 7,000. That means not greater than 7,000. You understand?
Yeah. It's not exceed 7K.
Yeah. So let's add more.
Can we just do it again?
What?
Can we do it again? Okay, when you want to do your constraints, you add.
Which of them?
Talking about the constraints, like this integer and 7,000, I'm saying.
Yeah.
When you want to do your constraint, I mean, you add, right?
Yes, you add. You
go to add.
Yes.
Okay, it's fine. Don't worry about it.
You add. Just click add.
Okay, you can just do it again.
Yes.
Okay.
So you click here, the reference cell, you choose the cell, okay? Then you choose the,
Sales.
yeah, like here, I want this to be int. Yeah, you click the reference cell again. You go to the next cell. We say we don't want this one to be greater than 7,000. So that's less than or equals 7,000.
Yeah.
So I don't understand.
What don't you understand?
Wait, the cell reference, you click on sales,
Yeah, let's do this.
then you say you
Hold
want
on.
to
Let's do
do
the third
int.
one now. Let's do the third one. The reference. You click the cell
All right.
reference. You move. Now we are dealing with unit cost. Click on the value for unit cost here.
Okay.
It will pick the cell.
Okay.
Okay. This unit
Yeah.
cost. What constraint do we impose on this now? It should not be less than. It should be greater than or equals 1,200. Okay.
To be greater than or equal to 1,002.
Yes. Okay. Okay.
Sorry,
So
sorry, I don't know if I don't know if I can ask a question.
please, you can. You can.
For the calculation, the first one, which is the sales,
Hmm.
we use Intel for that.
We
And
use
the price, we don't use
we
less
use
than. Is it not possible? Can we?
okay, go ahead. Yeah.
Uh,
It's not possible to do what?
and then for the price, to apply the same Intel formula, is it not possible?
Yeah, you see why we use this integer here. Integer simply means whole number. Okay.
Yeah.
Why? Because
Then we
this
shouldn't come up
field,
with any decimal points.
yeah, shouldn't have decimal points. Why?
Mm.
Because what we are calling sales here is quantity sold. Quantity.
Mhm.
Let's say you are selling bread, loaves of bread. You shouldn't have decimal. Is either you sell 2,000 loaves, you sell 5,000 loaves.
Yeah.
You cannot sell 1,000.73 loaves.
Mhm.
You understand? That's not
Okay.
possible.
Yes.
It has to be a whole number. That's why we set that
Oh,
to int.
okay.
But the others can be fractions.
Okay. Okay. Okay.
Yeah, that's the point. The others can be
All
fractions.
right.
Okay.
Okay.
Okay, so for price, we said price should be less than or equal 7,000, which means it should not exceed 7,000.
Yeah.
The unit costs should be greater than or equals 1,002. If we like, we can even still add an upper limit to unit cost. Let's say unit cost should be in the range of 1,002 to let's say to 4,000 or 5,000. Okay.
1,350.
Eh, eh, okay. So okay, okay. I'm suggesting 1,350. All right. So let's say it's something like that. We'll come to this unit cost. We'll pick it again. Then this time
Greater than.
is less than or
Okay,
equals
less than equals
1,350.
1,350.
Okay. So what we are saying here is that the price should be in this range. Price
Yeah.
should be it should range from 1,002 to 1,350. Okay, price should be in that range. Sorry, I mean unit cost. It's expected to be in that range. Then selling price should not exceed 7,000. And then what else? Sales must be an int. Okay, sales must be an int. So let's try to solve this. If I click, hope you saw what I did. Did you see what I just? Hmm? So what I clicked? I click on solve.
Lawrence Junior Rangers.
Solve. Then it's telling us something here. It says solver found a solution. All constraints are and optimality conditions are satisfied. Okay. Now keep solver solution, restore to original solution. I want to keep the solver solution. Okay, this is the solver solution that it has gotten for me. I want to keep it. Okay. So you can just click on OK. So see the solution that has gotten for us. Okay. So it's saying that if we have a unit cost of 1,286.99, that's like 1,287 naira approximately. And we sell at a price of 5,282, maybe 20 kobo or whatever. Like in Nigeria now, I don't know whether we can use all those kobo stuff. Maybe you just round it up to 50 kobo or 5,293. Okay, if we can maintain this and then make sales of 2,503, then we can have a profit of 10 million. So that's what Solver has done for us. But for you to do this, you have to take notes. You have to note that this your objective must be a calculated sell, right? It must be a calculated sell. It wasn't just typed, it's computed. There must be a formula here. Okay. The formula here is sales times price minus unit cost times sales to give you profit, isn't it?
Yeah.
Yeah, that is true.
Yeah, give you the profit. So it must be a calculated sell. If it's an ordinary sell that was just typed, there's no formula there. It's not going to work. So make sure your objective sell is a calculated sell. Without that, it won't work. So, is it clear to every one of us? Any questions?
That's good.
Solver can be used to solve much more complex complex problems. Okay, even beyond but we are doing data analytics, so we won't get into some of those other things that don't concern us, all that, because we have a lot to do. Okay, so this is an example of how you can use Solver to overcome the limitations of goal-seek. Note, when you are, you have to be careful when you are setting your constraints. Okay, you have to be careful. Okay, let me give you, let me see. For example, let's see. When you are setting your constraint should make sense. Okay. First of all, analytics is a real life thing. So you really have to know exactly what you are doing. You don't just set constraints for the sake of setting constraints. You set the constraint based on your understanding of the underlying scenario, okay? The underlying need. If it's a business, you should understand some things about that business, at least the basics that will enable you to do proper analysis. Okay. Now, when you say you want to make a profit of certain figure, you should know that you should not just change these figures anyhow because they are subject to certain constraints. Like I told you, for example, even this quantity we are talking about, I don't know if we set an upper limit for quantity. We didn't do that. But usually in real life scenarios, you may need to set an upper limit for that. For instance, let me increase this value to 100 and let's see what it's going to give us. Okay, so now let's see what is giving us now. Yes. Please, 1 minute, please. All right. Yeah. Thanks for the break. Okay, so what did I do now? What's your observation? What did I do? I changed the profit to 100 million, right?
Yeah.
So what has changed here now?
The sales, the price, and unit cost.
Sales has changed to what?
Well, 17,002 for
70,000 to something. Okay. Now, what if the production capacity is not up to that? Okay, it's possible that the production capacity is not up to that. So, how do we solve that? What can we do about that? Assuming the production capacity is not up to that, then what can we do? Let's say the production capacity is let's say 10,000. So we have to say we do that less than or equals 10,000. Hope you guys understand what I'm saying. Let's try to solve that. Can you see? This is an example of what I'm saying. You see, it couldn't find a solution. Couldn't find a solution. Okay? Now, do you know why it could not find solution? Okay? But I now changed it. I changed it to see what I did now. It couldn't find a solution because the constraints I have given, it could not find a solution, which means with these constraints, it's not possible to make this kind of profits that I'm asking for. Are you following? Do you understand? The way I understand that.
Yes.
So I'm saying, given these constraints, what are the constraints? Maximum quantity that can be produced is 10,000. Price cannot exceed 7,000. Unit cost has to be between 1,2 and 1,350. With all these constraints, it's not possible to make 100 million. That's what it's saying. 100 million, yeah. When you try to solve it,
It might exceed or might not.
yeah. So it's telling you it's not possible. Okay. Is that meaning what? Meaning what?
Meaning it might exceed the 100 million or might be below.
It might exceed. It cannot be up to.
Cannot be up to.
Yes.
Cannot.
So in this kind of scenario, what do? You try to find the maximum that can be achieved. Are you following now? Given these constraints, what is the maximum profit achievable? Since we cannot make the 100, what's the maximum we can make? So you choose maximum, solve. It will give you a maximum. You see, solver found a solution. All constraints on optimal conditions are satisfied. So this is the solution it has found. So it's saying that given this constraint that you gave, the highest profit that can be made is 58 M. 100 is not possible. Are we on the same page?
Yes, sir.
Not possible to make 100. So it's very, understanding how the constraint work is important, So you cannot see why we have this maximum and minimum. If the objective is to reduce something, that's when you talk about minimum. Okay? If the objective is to reduce something to as small as possible, talk of minimum. Minimize, like cost. But if the objective is to get something as high as possible, you do maximize. Okay. So that is solver. That's how solver works. Right? Okay. So now that we've looked at solver, how can we compare goal seek, data table, and solver? If I ask you to compare them, to say something about the three, how would you describe them? I mean, how would you describe the features, what they can do, the capacity of the three of them?
Okay.
Yeah. They give you various options to do especially if you are into manufacturing,
Yeah.
and you know, create different scenarios
Okay.
of how to balance the price of your goods,
Yeah.
taking into consideration the per unit cost,
Yeah.
and to also get the quantity, the right quantity that will give you the best options.
Results. Yes.
Yeah.
Yeah. Thank you. So in other words, they are used for what if analysis. What you just described now is what if analysis. Okay, so let's also look at in terms of the capacity, what's the extent they can go? How would we compare them? For example, let me start it for you. For example, we know that GoSeek can only handle one changing variable. Okay, what about data table and um, solver? So how if you want to put them on a scale, how would you compare them in that regard? My question clear now.
To my understanding, the last time when we use this a goosey,
Mm,
in order for us to have a higher percentage, as in higher profit,
yeah,
because first of all we talk about the unit cost, and we said that if we should increase the unit cost, that maybe customers may run away.
yes,
Then we now later decide on increasing the quantity in order for us to achieve a higher profit.
okay,
So that was calculation we did the last time, which I can still remember. We work mainly on the quantity while using this a good say.
okay, okay, okay. Thank you for that attempt. Now, we know that GoSeek handles one changing variable, okay,
One variable at a time. Yeah.
at a time. Data table can handle maximum of 2. Hope you know that.
Those multiple.
Yes, that's 2. Because why? Because for data table, you can have a 1D data table or 2D data table. Okay, like this data table now is handling
Yeah.
two variables, two changing variables at a time, which are the sales and price.
Right.
You see, that's for 2D. 1D handles only one. This one, particular one, is handling sales, just sales. Is changing the variable. Here, sales is changing, price is changing. That's two changing variables. Okay, and for both data tables and GoSeek, the objective is kind of the objective is somehow I mean, at least for particular values, the objective is kind of fixed. Like here now, you see, we are setting profit to 8,005 and all that. So it's kind of fixed. Okay, it's not as dynamic as in the case of solver. Okay, like here now, say when this figure is this, when this is this, you get this. Okay, But by the time you get to solver, with solver, you have more flexibility and more options. More flexibility, more options. More flexibility in the sense that for solver, you can decide to use it to set a fixed objective. You can decide to maximize, you can decide to minimize. Okay. And you can set multiple constraints the way you like. But the constraint has to be properly set anyway, so you don't run into problem. And of course, you can work with a number of changing cells, not just two. Okay. So solver is a lot more versatile. That's why I see it comes in as an add-in. It doesn't come by default. Of course, it comes by default when you install, it's there, but you have to activate it. Okay. Yeah, so that is that. So when you want more flexibility and you want to solve a more complex problem, then you may have to resort to the solver. Okay. Of course, in the last class, we also looked at scenario manager. So we are done with what if analysis now. Yeah, I said forecasting is used for projecting into the future. But forecasting must not be mistaken. Must not be mistaken for, well, we could say forecasting is prediction, predicting the future, yeah. Predicting the future, we could say that, okay, if we like, the future, but the term prediction, initially prediction, that word prediction